and welcome to the webinar today from TecQuipment and Matrix Technology Solutions. My name is Dion Knowles and I am joined today by Liam Walton from Matrix Technology and Kyle Hattard from TecQuipment. Are you there, Liam?
Yep, I'm here. Hello. You okay, Dion?
I am good, thank you. Ready to rock and roll today. How about you?
Yep, I think so. Ready.
Fantastic. How about you, Kyle?
I'm all good, thank you. Yeah, ready for this physics seminar. Talking all things physical about physics.
Brilliant.
Did you like that then?
Good. So to remind everybody who's watching us live today and those who are watching on demand, we're going to be looking at the practical teaching of physics from both a mechanical engineering perspective and an electrical and electronics perspective. We're doing this jointly with Matrix Technology Solutions so we can offer a comprehensive perspective on the physics A-level syllabus. Now, while we are focusing on physics A-level itself, we will also, this will be applicable to many other levels of physics teaching. So stay on as we take you through all of these areas of physics. Before we get started, we'll do a little bit of an overview of who TecQuipment is, who Matrix is. Some of you will know a bit about both of us. You can find out more on both of our websites. Then we'll have a look at the Physics A-level syllabus, and then we'll look individually at the mechanical and electrical elements of that and how you can use practical teaching apparatus to engage your students further in the syllabus and enhance their learning. At the very end, we will have a Q&A section. Now, don't need to wait till the end to ask your questions. Use the chat box and we'll ask them throughout the course of the session. If you're watching this on demand, the chat box will no longer be active. You can use the comment box and we'll come back to you in due course with answers to those questions. So do let us know where you're watching. Put your name in the chat box, where you're watching from and who you are, so we can give you a shout out. So let's start off by looking at the different companies. Those of you who know about TecQuipment, you'll know we're a worldwide organization. We have a worldwide presence in more than 100 countries, in 1,200 different organizations. We design and manufacture everything all under one roof in our Long Eaton factory in the United Kingdom. And in terms of history, we're over 63 years old and we go back to 1958 when two gentlemen met on a train. I'm not going to go into that full story now. If you want to know the history, then you can have a look at our website. What we're all about, though, is developing skill sets that deliver the best products for practical teaching of engineering principles, really enhancing and embracing real life understanding and improving students' employability. On top of that, we see ourselves more than just providing equipment. We want to be holistically involved and assisting in the teaching process. And as a position, having many connections around the world, we've brought together a global community of engineering educators through social community groups on LinkedIn, on Facebook, and then you can also find a community group tab on the YouTube area. We also look actively at how can we engage students beyond the equipment, like running student competitions. You can find out more about those on our website. When we're designing our products, we've got 3 specific principles of product in mind, and I'm sure Matrix will have similar principles in mind when we hear from Liam shortly. And the most critical one is fostering curiosity and sparking passion. That's what we're all about, engaging students. But at the same time, we're constantly looking at making sure that the products can stand the test of time. So we've got equipment that goes back to still being used from the 1960s. And wherever we're developing new products and enhancing existing products, we're looking at how can we make products perform faster and be more effective without compromising the learning outcomes. Well, that's it from me introducing TecQuipment. At this point, I'm going to hand over to Liam, who can tell us more about Matrix.
Thanks, Dion. That's great. Okay, so we are Matrix Technology Solutions. We are a small company based in the United Kingdom as well, not too far from TecQuipment. We're a little bit further north in England, in a town called Halifax in West Yorkshire, just about 30 miles away from Manchester. We are 27 years old. Matrix began by developing CD-ROM based solutions for education in the 90s. And that continued. Our business has diversified vastly since the turn of the century. I guess by the demands that the internet has brought along, a lot of CD-ROM content became freely accessible online, and so we've had to diversify quite rapidly. We've adopted a number of different product ranges. Today we're going to talk about one or two of those, but there's a lot of different products that we have to offer, and we cover a whole range of different disciplines, target markets. So we cover science and physics as one, which we'll talk about today. We cover computer science. We'll touch briefly on optics, fiber optics, and photonics. Engineering is a big discipline for us. So electrical and electronic. We have a few products in the mechanical area, although that's definitely more of a specialism for TecQuipment. Robotics, automation, manufacturing, and then products for aviation, automotive, and electrical installation. So we have a whole range of different products in all those different markets. We have a number of what I would call key features to our products that we kind of try to put in people's minds when we talk about them, and those are the quality. Much like TecQuipment, our products are all manufactured here in the United Kingdom under our own factory here. So we're producing quality equipment. We're producing equipment that's going to be long lasting, that's going to be rugged, that's going to stand the test of the tests and demands that are put upon them in an education environment. We also produce quite compact solutions. So we produce equipment that can be portable, moved lab to lab. We have relatively quick lead times. We produce quality curriculum, and again, I'll touch on that throughout this presentation, this webinar. We're generally producing safe, low voltage equipment, so there's no issues around safety for students. And by and large, the equipment that we supply is affordable as well. And so there are a number of things that we like to put in the mind of a potential or existing user of Matrix equipment. So I'll build on more of that throughout today.
Brilliant, thank you for that, Liam. So you've had a company overview. Do remember, this is a live webinar and you can use the chat box to ask your questions as we go through it. Now, you most likely haven't had any questions yet, but when we get in talking about the physics syllabus and what is offered by both TecQuipment and Matrix, you very well may have some questions that you want Liam and Kyle to answer. So Kyle, tell us more about physics in terms of specifically physics A-level syllabus, so that we can get the scene there.
Yeah, thanks, Dion. So the physics A-level and the syllabus, obviously there's various different providers. So we've chosen AQA to reference today, just as a guide as to some of the content that would be involved. And obviously physics as a subject is fascinating, but also the opportunities that allows you to then take further in relation to study as an undergraduate or further interests from an industry perspective. The physics A-level really creates a good solid foundation from a mathematical and also engineering and a sort of electronic basis. And one of the reasons obviously we're doing this joint webinar with Matrix is to obviously share the fact that they've got such a good extensive electronic range of products which complement the physics syllabus, and likewise as we do with the mechanical side of the syllabus. So there's 8 core competencies within physics. So that covers measurements and their errors. So that would be, for example, covered by our calibration equipment, the TD400. Particles and radiation. We've got waves, mechanics and materials, electricity, further mechanics and thermal physics, fields and their consequences, and nuclear physics. You've then got 5 further options: astrophysics, medical physics, engineering physics, turning points in physics, and electronics. So you can then take that fundamental basic and then develop it into something that you want to, or the academic that's obviously running the course. So effectively, within the practical element of physics, there's 12 required practicals to be carried out. And from the TecQuipment perspective, these would cover activities such as determining the G value by a free-fall method. So that would cover some of our engineering science kits. We'll come on to that in a little while. The simple harmonic motion using mass spring systems, Boyle's law, temperature constant, and Charles's law, pressure constants, and investigation into the inverse square law for gamma radiation. So that's a little bit of an insight into how some of the practical experiments that are essential within the physics syllabus are able to be carried out with some of our equipment. And Liam will obviously come on to the aspects of the syllabus that are touched on in regards to electronics and electricity. So that's a little bit of an overview really, Dion, in regards to physics, and obviously the platforms that students can then evolve into, and obviously creates a fantastic platform for moving into a engineering degree, and understanding obviously the basics that you need for that.
Yeah,
so,
I think just Kyle, just to add from my perspective to what you were saying as well, you know, there's it's a brilliant qualification to have to set yourself foundation for learning about further physics at undergraduate level, or even to go into engineering with you know, with what's involved there. And I do think that our two companies, you know, we complement each other quite well ourselves, mainly from an electrical perspective, and the units that are there, both mandatory units and optional units in electronics and electrical studies, and what TQ have to offer from a mechanical perspective as well. I mean, even looking at some of the other, and I don't go into this in a few moments, we'll look at some of the specific you know, sets of equipment that Matrix offer that can, and TQ as well, that can do, you know, that can be supplied for the study of this particular qualification. One of the things that I don't touch on in my presentation, but interestingly enough is present within the AQA syllabus, is the sort of topics around diffraction and refraction and this type of thing as well. In fact, I don't know whether, Dion, do you have the web page up that I sent to you earlier?
There you go.
There we are. Yes. So that's the Matrix website, actually. If you just scroll a little further down this particular page, Dion, there's a number of products that could be seen fit and familiar for you know, for that particular syllabus study. You've got the kits there at the bottom, the FP8197 and FP8104, which are the reflection and refraction kit and the diffraction kit as well. And I believe that we also have, in fact, we do also have a combined kit that brings those together, which is known as our advanced physical optics kit. These kits, in fact, are used at the A-level level of study, but are also used through undergraduate level, even into postgraduate study as well. So we do have at Matrix equipment to be offered for some of the units, other than just the electrical and electronic elements of what's there within the syllabus.
Great, thank you, Liam. So I think at this point we can delve into looking at the mechanical aspects. Kyle, are you ready for this?
Yeah, absolutely, Dion. Let's give it a shot.
Okay. Let's look at mechanical. Don't forget to ask your questions in the chat box, people. Over to you, Kyle.
Cheers, thank you, Dion. So if you just tip the slide, Dion. So obviously that's a brief sort of summary introduction into the areas that we'll be covering: material testing, properties, thermodynamics, that kind of thing. So the basics really of engineering science, and again, the engineering science equipment are a fantastic fundamental introduction into the foundation of engineering, really. But also it stretches into basic mathematical modelling, you know, trying to obviously understand theories like gravity, the determination of G, and a free-fall method, as I mentioned before. So a particular kit that would perhaps help you with that would be maybe the ES9 or the ES10, which is our pulleys or kinetic energy kit. So it really does allow students to get to grips with a variety of different investigations, really. You know, from forces to friction on an inclined plane, to bending of a beam, to torsional forces, polar moment of inertia. And they're really compact, great pieces of kit to just have on hand, you know, even if it's for a rainy day. So yeah, they're really, really good for that.
Exactly. It's a rainy day here and I have some kits in my other room.
Well, you'll never be bored. You'll never be bored.
Maybe I'll assemble a gear trains kit or something in the meantime.
Yeah, you should determine gravity for us all, Dion. That's what you need to do.
Okay, I'll just bring an apple.
Yeah, absolutely. So obviously, you know, these are a great tool really for any academic, but obviously from a physics point of view, they form a very useful tool to be able to deliver essential parts of the syllabus. And from a practical aspect, we obviously then move into the SDF boards, which provide an investigation into the variation of the frequency of stationary waves on a string length, tension and mass per unit of the string as well. So that's particularly part of the syllabus within physics. And one of the particularly interesting aspects of that would be the suspension bridge apparatus, the STF2, if you're interested in finding out further information on that. That demonstrates it very nicely, which you can see in the bottom left-hand corner of the image there. And obviously as well, polygon of forces and equilibrium of a rigid body. That's another really useful reference, and that's the kit that you can see in the center. And again, determination of G from a free-fall method. You can see that in the top right-hand corner. So yeah, it's obviously really useful, and these are really good for getting a number of students around. So they're about 1 meter squared in size and give a really good application to actually understand these physical principles. So you can see a video there that Dion's just skipping through. That's in fact an academic from Lincoln University who talks about how he found using the statics board really useful in application within their engineering course. So yeah, they form a really powerful tool. He's got the tensile tester, Dion. So
that's right. I was just skipping to that because I know we're going to be coming on to that later. I just wanted to show people that in use. Interestingly, what they do there is they don't just use it that test the metal specimens, but they also use it in their textiles lab as well. So there's many cross-functional uses, and they'll be looking at different weaves and in textile restoration. Just a bit of an extra fact there.
Absolutely. Yeah, nice one. Cheers, Dion. Yeah, and I think that's the thing. It's the beauty of material science. Obviously, you know, that equipment covers a variety of different applications. So very versatile indeed. So if we move on to the next slide, Dion, that would be really good. And we can hop into discussing materials. So strain analysis. Strain analysis, why is that important from a physics perspective? Well, understanding obviously how are you collecting the information that you're going to use in understanding how a particular material is behaving. So here you can see a strain gauge analysis trainer effectively, and you've got a variety of different forces that are applied to either a bar or twist to a bar, so torsional effects on the strain gauge, and then obviously allowing students to really grasp the concept of how that information is collected and how varying different materials have an impact on that strain gauge result. So moving into the materials section, which is, if anyone's interested, 3.4.2.2 of the AQA syllabus. So you can reference that directly. And again, it forms part of the essential criteria for practical experiment, covering Young's modulus. So Young's modulus is effectively tensile stress over tensile strain. So tensile effectively means that the material is being pulled apart rather than in compression, where it's being pushed together, sorry. The great piece of kit for doing that is the SM1002, and that's a benchtop piece of equipment that allows you to insert specimens, and then via a screw thread, you obviously then apply a tensional load, which is then gauged via a strain gauge system on the left-hand side of that image. And the great thing with this piece of kit is that obviously you get to feel the elongation of the material through the screw thread. So you're not disconnected to the material through the use of any hydraulics or electronic actuation system. It's purely through the screw thread. So the student gets that material feedback, or as we call it at TecQuipment, engineering empathy. So that's obviously a really good way of demonstrating to students Young's modulus. And obviously, like Dion suggested, you can explore different options in regards to materials with that piece of kit across multiple departments. And then you move into the smaller tensile tester, which is more benchtop sized and more on a one-to-one basis for students to understand the basics in regards to how the materials are reacting. And you're able to then plot the curve from a series of data points that you generate from the force meter there. So if we move then into the next slide, please, Dion, that's brilliant. So we're looking now at the harmonic motion part of the physics syllabus. And this is all about obviously understanding simple pendulums, moving to the more complex compound pendulums, which then form the basis of how gyroscopic theory begins, and also moving into harmonic motion using a mass spring system, which again, the mass spring system and the single pendulum both form essential parts of the practical experiment. So there you have the TM164, which is a mass spring system, allowing students to obviously carry out the practical aspect of that and understand the theory. So then we are moving into gas laws, and this is part of Physics AQA 3.6.2.2, ideal gases, the TD1000, and also the TD1004. So yeah, that allows you to obviously understand Boyle's law, gas constants. Yeah, it's a brilliant piece of kit, to be honest with you, and is used throughout universities across the country in regards to basic thermodynamics principles as well. And obviously from a physics point of view in the AQA syllabus, this is a really great piece of kit that allows them to obviously use the equipment from a data acquisition point as well. And you've got a if you've got a laptop or a software application, you can draw the data through our VDAS system and obviously then generate your results in graph form. So that's the gas law side of things. If we then move into, I think it would be the gamma is the next one, Dion. So you effectively within the syllabus have to understand inverse square law for gamma radiation, and that's our TD1003. And there's a nice little video actually, Dion, that summarizes this piece of kit really nicely. But it's about understanding wavelengths and radiation.
This particular video here is one of the student competition entries from Nottingham Trent University. Every year we hold a competition with students there where they look at mechanical theory and then use the pieces of equipment to prove it. So here I think they were looking at the different radiation properties on different fabrics, so you can actually see it in action. That's a student team's entry in there.
No, that's great, that, Dion. It's really, obviously, seeing students using that in application is brilliant, and obviously, seeing how they're using that in an alternative way as well. you know, to generate results and work as a team.
We're checking out our playlist, which is student competition playlist. So there's lots of different videos on there, which was these were made by students themselves. They came up with the concept, they created the video. We haven't adjusted them in any way. So go and check those out if you want to actually see students hands on with this. There we go. Over to you, Carl.
Brilliant. Cheers, Dion. I wasn't sure whether you were playing the video then or not. So if we can move to the next slide, because we go then into thermal energy transfer, I believe, which is emissivity and thermodynamic principles. But obviously linear heat conduction and the first law of thermodynamics. So you've got there the TD 1002 and an ancillary, the linear heat conduction experiment, the TD 1002A, which basically allows you to insert a specimen into the center, and you've got a variety of different material types that you can utilize, and you measure the temperature rise across the 2 points, and effectively you've got 7 actual thermocouples that you can take a reading from, so the student can really understand how the effect of the heat is being transferred through that material. So also I mentioned before the TD400, which is our temperature measurement and calibration equipment, and again that forms part of the essential requirement for the physics syllabus, and again that piece of equipment allows students to really get to grips with different calibration and measurement method, if I can get my words out, different calibration and measurement methods. So yeah, it's a really, you know, a really useful piece of equipment for that as well. So yeah, moving into the next slide, Dion, which I think takes you into the Peltier and Seebeck effect, which, referring back to the syllabus for physics, you know, generally this is a really interesting theory anyway, with the Peltier effect, and it's effectively being a bit crude, but where you see a temperature change over different material types with a current that's induced into 2 various different materials, and often this kind of equipment is used in a small portable fridge, for example. So maybe a motorhome may have a Peltier and Seebeck effect device that will allow the fridge to operate without any compressor or gas that's required in there. And as far as the physics syllabus, this is a really useful piece of equipment in understanding the electromotive force and internal resistance of cells by measuring the variation of the voltage of the cell with the current within it. So you can see there from the diagram different polarity, and obviously how that then is affected from the material type. So yeah, that's obviously a bit of an intro in regards to physics and how that affects what can be used within the syllabus. And lastly, we move on to the solar heat transfer, the photovoltaic cells, the TE4. And this really allows students to understand the relationship in a practical applied sense between voltage and current, with a power output display within the VDAS application, displaying power over the surface area, and along with understanding how the ambient temperature and the array angle, the angle that the device or the solar panel is placed at, has an effect on the performance and power output of that equipment. Really, this leads nicely, to be honest, Dion, into Matrix portfolio and how they can assist with the physics syllabus.
I think we might have one thing that might have been a bit random there that we forgot to cover earlier, and that was the gyroscope, though.
Oh, brilliant. Okay, yeah, we can go back to the gyroscope. So we mentioned about simple harmonic motion and how that evolves into compound pendulum theory, and obviously acceleration, and how forces affect, you know, the acceleration and the gravity of an object. So the gyroscope piece of equipment really allows students to understand the theory and the mechanical principles behind that, and obviously that relates back into the physics syllabus as well. And one sort of reference that I always like to use with gyroscopes is, you know, imagine having a bike wheel between your two hands, and it's spinning, and that force that you can feel from trying to then move that bicycle wheel away from the center point that it's spinning nice and freely in is the gyroscopic force or gyroscopic effect. So yeah, that's just a bit of an indication. But this piece of equipment allows you to obviously extrapolate that information from a theoretical point of view, and really allow students to understand this theory really well.
Brilliant. Okay, thank you, Kyle. As you said, it leads nicely. Before we went back to gyroscopes, it would have led very nicely into what Liam's
Never
going
mind.
to talk about. Over to you, Liam, to tell us more about your element of physics.
Of course, brilliant. Okay, so from a physics perspective, the main kind of matrix and what we offer are a range of products called Locktronics. Now, I'm sure that there'll be people watching this, either live or on demand, who are very familiar with Locktronics because it's a brand and a resource that's been around in education for many years. It's been around for decades. It's a resource that's used to simplify the process of learning and teaching about electricity and electronic principles. So we are the developers, not the developers, we are the new developers as of the last 10 years. We weren't the inventors of Locktronics. We bought the brand, we're the only manufacturers of the range. And in fact, I think it was previously a brand that was offered by TecQuipment, interestingly enough, more than a decade or so ago now. And we have a whole range of kits, solutions, and components and curriculum for teaching about various topics, various principles that can be utilized in electrical and electronic areas and study. So we have a whole range of components, as we saw there on the previous slide. Essentially, the way that the system works is very straightforward. We produce curriculum. So I have a curriculum book, for example, here in front of me. Okay, and I believe we have more than 40 of these now. Every set of equipment that is developed has specific curriculum workbooks that come with them. We have specific kits, which I'll come on to in a few slides' time, that are suitable for the A-level physics syllabus from AQA, for example. In fact, they're written pretty much to the specification that's outlined there. The way that things work is the student takes the curriculum, they take one of the worksheets, they then take a baseboard, and they follow instructions that are given to them on the worksheets. So it's great for teacher-led learning. The Locktronic system is also great for individual student learning. The boards are relatively small in size. I have one here next to me with a few components slotted on. So you can see from that it's relatively straightforward to have that as a desktop piece of equipment where students can build together circuits and study in that particular way. At the moment as well, it's also because of the way that we present the Locktronic solutions, it's a lovely way for students to even do some learning out of the lab or out of the classroom. I've been in touch with many colleges, universities who are utilizing the Locktronics kits. And at the moment, with all of the challenges that we have facing us with the pandemic around the world, they find that these solutions, the way that we present them in trays that can be packed away, that they're letting the students book them out and take them home and self-teach following the curriculums that we provide. Okay. The great benefit of Locktronics is that as students construct a circuit, they see the circuit diagram in front of them. Therefore, they easily link theory to practice and are able to simplify the learning process. So Locktronics, in short, makes learning easier. It saves preparation time. It lasts. Each component includes circuit symbols these circuit symbols are heat embossed on, so there's no way that students are going to be able to scratch those off. As I said, the kits that we supply, which meet the demands of specific curriculum, including the A-level physics curriculum and the electrical and electronic modules of that specific curriculum, they are all supplied with what we call inlay sheets. So at the end of a lab, or when the student returns the kits, it's easy to see what's missing or whatever. And they're rugged as well. It lasts a long time. You know, these kits, much like the equipment that Kyle was talking about from TecQuipment, these kits are kits that have, you know, can be used for decades in the lab. You know, it's not something that you're going to buy and then the following year is something that needs to be replaced. So, physics, science. You know, looking through the A-level physics syllabus, there are a few kits that really stand out in the matrix offering as being applicable to deliver the learning outcomes that are demanded from this syllabus. And the first of those is kind of what I'd say, I'd call it a second tier kit from Matrix. And that's the kit that's known as the Electrical and Electronic Principles, LK9329-2. This kit is supplied, as usual, in the storage boxes. We supply with international power adapters. The curriculum, incidentally, there are 2 curriculum workbooks for this particular kit. We provide all of the curriculum completely free of charge on the website, a kind of a different approach to others in the market. We have on our website what we call the Learning Center, and that's just in the website. You go down to support and then into the Learning Center. For every kit that Matrix provide across not just the Loctronics range, but all of our ranges, it's always there and available in PDF format and on request editable format as well. So this kit, the LK9329, covers a whole range of topics that are required to be delivered, you know, in the A-level science. It's involved in covering circuit symbols, conductors and resistors, Kirchhoff's law, AC principles, Ohm's law, measuring current, measuring voltage, and so on. And all of this can be seen through the curriculum workbooks. We then have what we call the A-level class pool extension kit. The extension kit is one kit which is designed to be added to the LK9329. And this goes into other optional modular areas of the AQA A-level physics. They would namely be operational amplifiers, digital electronics, energy in the environment, and PIC microcontrollers. So this is a kit that can be added in order to get all of the learning outcomes that can be delivered by that particular kit. So within energy and the environment there, we focus on wind power, solar power, storage and controllers. Within digital electronics, we focus on analog versus digital. We also focus on logic gates, NOT and NAND, OR, NOR, and XOR. 3 input gates. We talk about programmable logic there as well. The extension kit allows for study of PIC microcontrollers as a pre-programmed PIC device can be utilized. And then we have the operational amplifiers strand to this as well. So different amplifier types, active filters, relaxation, oscillators, and so on. Okay. One of the other items, products, I guess, that I wanted to talk about is something that's relatively new to us. Now, with the LK9329, which I spoke about a few moments ago, and with the extension kit, there's a requirement for a signal generator and external PSU to be utilized by by the user essentially for many of the experiments. Now, what we have is what we call the source. Now, source is essentially an AC, DC, PSU, power supply, and signal generator in one unit. Essentially, it's housed in a rugged enclosure. There's a large graphical backlit display, input controls on that particular display as well. It has a number of DC voltage outputs as well as DC and AC outputs. We supply this as a 110 volt and a 240 volt system. So it just basically allows the user in the lab to cut down and reduce space. There's no need for the separate signal generator and power supply any longer. And it's a rugged unit that can be utilized along with the kits that we've got. So it's an optional yet really practical unit that we kind of tend to find has outcomes in the A-level syllabus for users. Okay. So when you look at the AQA, AS and A-level syllabus, 7407 and 7408, the kits that I've just shown mainly support delivery of the electricity unit, which is one of the units in there, but then you have the A-level only electronics unit, which is optional, for which we are able to cover with the equipment that I've just mentioned. There are also a number of learning outcomes for delivery of other units as well. So you've got units there about fields and their consequence, electric field strength, capacitance and magnetic fields, for example, and all of that can be covered using the equipment that I've just talked about. Unfortunately, I'm not quite as well versed as Kyle with the unit numbers.
Help you with that. I can help you with that. Don't worry.
Okay. The other thing I wanted to just show as well, Dion, is it worth me, because I've got a circuit here set up next to me, it might be worth me just switching my camera over and showing that, because I know that we sometimes are able to just get something on another camera for you here. Just give me a second. You're probably going to see me initially. Yeah, but you can see me from a different angle, from my good side. So let me, if I disappear momentarily, I will switch it back on. Sometimes the connection is just a little bit loose, let's say, on that. Okay. Yeah, you've lost me there. So I'll come back on. It won't take a moment. Okay, you can see that, Dion? Yeah?
Yeah, we can see that clearly. Thank you.
Okay, so now this is not specifically applicable for A-level physics, unfortunately. However, what I wanted to just show here is how far you can take things with Loctronics, because there's sometimes a perception with Loctronics that it's a resource that's used mainly within the school's environment. But what we have here is something that we've just, in fact, we held a webinar about this on Tuesday, which I can provide links to if required, but this is for the automotive sector. So what you have here, at the back there, you might just be able to see a coupled motor. So that's a brushless DC motor driver. And essentially that's mimicking what would be happening in an electric vehicle, where you've got a small brushless motor on the right side, the black motor there that's been driven by the DC silver motor to the left. And that's providing power into this particular circuit. Now, this circuit here includes a number of lead acid and lithium ion batteries, which are encased in the metal enclosures here for obvious safety purposes. And then you've got some really complex circuits in the middle here. And so it's just outlining the sort of length that you can go to when using Loctronics outside of a school environment and into a college and even university environment as well. We have some really nice case studies from the likes of University of Bradford, where these guys are using these kits that we've talked about this today on the webinar for teaching students at undergraduate level as well. So yeah, I just wanted to pop that in there so that people could kind of get a vision for how far you can go with this system and where it can take you. And this is automotive focused, but still very much gets across the key principles that I'm trying to talk about, I guess. Okay.
Nice. I think that was really helpful to see the real life setup there. Thanks for that. I feel like we're lacking. I feel like I need to go and get that engineering science kit and quickly put a chain drive on. But I'm not that efficient.
Should be by now, Dion. Come on.
I know. I'll take the pressure.
No, I think Liam, that was brilliant, because obviously, seeing how something that's so relevant to the marketplace nowadays, especially, with electronic drive transmissions and that sort of thing, it's really key thing.
Yeah, absolutely, for sure. Yeah, and we're supplying in the automotive sector, for example, the electronics range. We're now supplying the likes of Tesla, Jaguar Land Rover, BMW, Hyundai, and they're using this system for teaching their technicians, teaching students within their academies about key principles. Because a lot of the time, as much as we would like to think, we teach students very well. Often they'll come out of a school environment into a college, or even out of a college into a university environment, and have to go really right back to the basics. And using a safe system like the electronics system, not just in those sectors, but also in physics environments as well, and using something that's running at 12 volts and no chance of doing any damage to the students. It's affordable, it's easy for them to pick up and learn, is really effective.
Brilliant. I think I need to have a go with one. Can you post one to me, Liam, so I can
Absolutely.
have a go?
Yeah, of course.
Great. So I believe that pretty much wraps up all the practical teaching elements from the Physics A-level course from both Matrix Technology Solutions and TecQuipment Limited from Liam and Kyle today. I want to remind everybody who's watching this live, you can ask your questions in the chat box. So far, everybody's a little bit quiet on the chat today. So I want to encourage you to come out your shell and ask those questions before we wrap up for today. Now, I'd like to ask a question to Liam about COVID-19, I suppose, and how you're using electronics in that. You kind of suggested it earlier, how it could be used. Are students taking them home, or are they doing them in lab sessions in groups using the electronics kits?
It varies, to be honest. I mean, much like TecQuipment, we're a global, worldwide organization in that, we're supplying a lot into the US market. We're supplying a lot into markets in Asia, in the Middle East, and so on. And it does vary from market to market. In the US, for example, I've come across more scenarios and situations where educational establishments are able to source funding, which will allow them to purchase this type of equipment, not just the electronics, but as a company, we also develop, for example, a range called Automatics, which is for study of automation and pneumatics. And these kits are, in a similar way to electronics, relatively affordable and portable. So there's no high voltages involved there. It's safe for the students to sign them out and take them home. And so in the US market, I have found quite a lot that where distance learning is taking place, there have been circumstances where they're purchasing these kits in order for students to take them home and learn. In other markets, I know that they're trying to get towards in fact, the US is one of these as well, where sometimes you go into certain states in the US and it's almost as if, what's happening in elsewhere is not going on. And actually the students are still getting into the classroom in smaller groups. Electronics is the type of equipment that works best when students are working in pairs or in threes. So it's not generally a demonstrator set of equipment that the teacher or the lecturer would have up at the front. But we do also offer options such as our demonstration panel. And I have seen also circumstances where teachers are delivering teaching over Zoom or over Microsoft Teams, and they have a panel, one of our demonstration panels at the front of the class, and they're teaching over video link, over Zoom or Microsoft Teams. Do we still have Dion? Kyle, can you hear me?
I'm not sure. She's frozen out.
I don't think I sent her to sleep with that explanation about lockdown. Hopefully not. Well,
No.
we'll keep people moving anyway while
Yeah,
Dion's getting back on. What about your experience, Kyle, with COVID?
Yeah, no, absolutely. Great question. I mean, in regards to obviously academics, this blended learning concept has come back online, you know, and is really being thought of the new direction. I think obviously practical learning is going to be utilised quite heavily at the back end of next year. But, you know, the interest and the importance of obviously carrying out experiments is still there. And it's still a huge value to the students' experience. So.
Yeah, for sure. And you know, you can't teach these type of topics for physics and engineering without getting hands-on. I think it's very difficult to envisage that ever happening. And so getting your students back in small groups is quite fundamental to that, really. Dion, we've got you back now. That's good.
Yes, I don't know what happened there, and I'm not sure whether we stopped live streaming or whatever happened, but we're back.
Great, good.
So you covered that, Kyle, because I was going to come back to you and say, well, what talk about VDAS, but I guess
talk about VDAS. Yeah, I mean, obviously VDAS is critical to every piece of equipment, and obviously the engineering science kits don't allow for VDAS, which is for anybody that's not aware, versatile data acquisition software. And that allows you to extract basically the data that you're generating with the practical equipment, and then generate graphs, interrogate the data, calculate various different formula. So yeah, really useful piece of equipment that will assist you in obviously delivering that content. So yeah, that's pretty much a bit of a summary, really, Dion.
Well, I think a good example would be the likes of Trafford College. We had Oliver Shaw, lecturer from Trafford College, on one of our Q&A sessions a few weeks ago, and they were explaining how they'd returned to lab sessions, but they'd done it in a very safe, structured way by having small groups of students. But they were using VDAS, so they might set up a Microsoft Teams session, have a group of students where they would rotate the students around for different lab sessions, and then stream that via webcam. And then you could also share your desktop, so you could have the VDAS on your desktop and share that live data with students who are watching, say, the Microsoft Teams or the Zoom or the WebEx or the GoToMeeting or whatever platform you've got. I've covered 4 there. I'll have to see if I can think of some more for next time.
Yeah, no, it's a very competitive market, that world, I think. So yeah, it's interesting, all the different platforms that exist for allowing you to obviously present the information remotely. But obviously it's the go-to at the moment. People are still enthused with obviously carrying out practical experiments, and it just shows you the importance of how that demonstrates you know, principles to students and who are trying to grasp an understanding, or even exploit and further on the mathematical principles as well. So I still, you know, it's a very important aspect of obviously a student's learning curve. So
I think from what I was speaking to, we had a guest in our Q&A yesterday. We had Isaac Whitehouse, and he's a graduate coastal engineer, and he's got friends who were still students. And he was saying they've missed lab sessions. And I was asking, if he was in their position, what would he be wanting and what would his concerns be for September? And he was saying, well, I've been demanding that I have my lab sessions, all the lab sessions that I missed, I have them again, plus all the ones that are due. So that we might find that there's a whole lot of, you know, a big lost period where everybody needs to catch up with all their lab time. It's when that period can resume once more, and under what conditions.
Yeah. No, I absolutely agree with that. And I think the important point to make with that is that when you are returning back to your labs and you are carrying out practical experiments with students on site, you know, it's going to be, lab time is going to be critical. So making sure that that time is used most efficiently and familiarizing themselves with the equipment that they're going to be using will really help them do that. So something like our structure software, for example, Dion, that allows, you know, students and academics to familiarize themselves with the equipment in a safe remote environment at their leisure. And then obviously when they're returning to the labs, they can make the most of the time that they have in front of the equipment, because obviously there's going to be a time pressure in regards to that. So yeah, there's lots of ways to think around it. So yeah, have we lost you again?
Oh yeah, it does look like that.
Yeah.
I was going to say, Liam, that probably applies to you as well with your learning resource online, where you can be encouraging, academics can encourage students to go on there, access that content before they get into the lab, familiarize themselves with what they're going to be doing.
Yeah, definitely. You know, we try to publish as much as we can online from that perspective, because and particularly at the moment as well, you know, we're trying to publish more, you know, than we normally do online, and in fact all of our curriculum there, so that a lot of theoretical knowledge can be gathered by the students before they come into the lab. And we have for some of our other product ranges away from physics, we have software based applications. We have a software called Flowcode, which is fantastic, and Flowcode has simulation capabilities as well. This is a microcontroller programming environment for Arduinos, PICs, and this type of thing. So microcontroller systems. Maybe some loose ties there into the physics world and what you've got in the syllabus here, but not too close relationship. And yeah, that is great for simulation, using at home, and then the students coming well prepared into the lab for say a session a week or something, where they can say, right, you know, I've been working at home on my project. We've had it back and forth with the lecturer. I've tweaked it. I've debugged it. I've got it to a point where I think it's going to work. You know, when I get it down onto the hardware, and there you go.
Brilliant, good. Well, I think that pretty much wraps us up for today. We've had no further questions come in from the live viewers, so thank you very much. Before we go, Liam, I think you've got a webinar coming up next week. Perhaps you'd like to tell us a little bit more about that.
Of course, yeah. On Tuesday, 7th July, 10 a.m. UK time, we are running a webinar to explain more about our new robotics product, which is a robotic arm. We already have a robotic arm in our range. This is a new version that we're releasing with new features. It's more rugged. There's a link there to our website where you can sign up to the webinar. Don't hesitate to get in touch if you'd like to find out more. And yeah, the robotic arm is a really flexible resource for learning about programming, robotics, and it's applicable to many various qualifications, units within BTech, for example, in the UK and so on. So yeah, we're running that next Tuesday, and it'd be great to have people along. Our webinars run a little differently to the ones arranged by TQ. So you sign up online there, and then we send the link over for you to join.
I have posted that link in the chat box. So if you want to access that, just simply click on the link in the chat and it'll take you through to this web page. TecQuipment also has more webinars coming up throughout July. Keep an eye out on our social media pages for news on those. We've got more live Q&A sessions as well. We are joined on the 15th of July by Roger Penlington. He's from Northumbria University, and we're going to be talking about blended learning in particular during that session. Towards the end of the month, we're also going to have a bit of a reflection on the period of webinars and Q&As, looking at some of the funny outtakes, the technical problems, all of those. And it would be great to hear from you. What were your favourite moments? What were your funniest moments? What were your worst moments? I can certainly think of a few myself of all of those. Anyway, thank you so much for joining us today. Liam, thank you very much for partnering with us on this webinar.
Thanks for having me, and thanks for partnering with Matrix as well.
Fantastic. And Kyle, thanks for all your hard work as ever. Brilliant.
You're welcome. Cheers, Dion.
Thanks, viewers. See you again next time. Goodbye.